next question we have is, do they belong to the class of forever chemicals? I'm not sure what they mean by they. Most probably the BTP compound that you were mentioning. So do they belong?
So this is a very good point. I mean, we are, I think, all aware about the next challenges in organofluorine chemistry, especially with PFAS. The BTP with the CF3 linked to carbon belong to indeed to the forever chemicals. But I think, as I mentioned during my talk, what the next important step we need to move forward in this field is to move to emergent fluorinated group, because now we have no longer PFAS anymore, and we still have very interesting properties. So if you look at the CF3 and just adding as SCF3 is no longer a PFAS, and you have same electron withdrawing character that you might need for your chemicals, for instance, and higher layer pupillicity. So I think this is where we need to go now.
Thank you for your response. The next question, it is regarding the residual selectivity. Is the residual selectivity of the difluoromethylation always complete?
Yes. So we were very pleased to see that this secondary amide was enough to strongly get the Z isomer. And thanks to the fluorine NMR, we are very happy. I mean, it's very easy for us to see we have second or only one ratio isomer or two. So, and we were very pleased to see that. Yes, this was very efficient.
Thank you. The next question, how stable is the ruthenium complex A that you have shown in slide 10?
Oh, it's quite stable. I mean, we prepare it thanks to the protocol developed already in the literature. And I mean, and we were able to prepare it and just to use it. So I think it's quite a very good alternative to what we have been done so far. Although quite restricted so far to only a couple of examples, but could bring some new added value to what we are doing in site activation.
Sure. Thank you. Moving to the next question. What is the rate determining step of the ruthenium catalyzed hydroarylation reaction that you have shown?
Oh, it was a CH activation event, the formation of this bis cycle system. Since we start from this ruthenium cycle, then the next step was a CH activation process, which can give you the directly the formation of this bis cycle as a key intermediate.
Thank you. Is it possible to achieve difunctionalization at alpha position using the Munawati reagent?
Alpha position of which derivative?
Alpha position of the amide.
I mean, for the SCF3, this has been done on specific substrate, like so I would say in principle it might be feasible, but probably with different pathway, mechanistic pathway.
Thank you. A similar question. What is the possibility of difunctionalization instead of hydroarylation to achieve some tetrasubstituted olefins?
I'm not sure I get the question.
Like most probably did. Since you have shown hydroarylation, is it possible to carry out aryl functionalization, like instead of trapping a hydrogen, can we trap some other functionality like difunctionalization, so that instead of a tri-substituted olefin, we get a tetra-substituted olefin?
I don't know, because maybe if we design properly the molecule and use again the derating group to ensure second CH activation on the remaining CH bond might be possible, but with the process we have developed, I'm not really convinced that this will be possible. But definitely this is something very interesting to see, and a couple of groups already start to investigate this double CH activation event in a sequential manner.
Okay, thank you. So we have another question in the chat box. Can you please suggest any method for trifluoromethylation on phenol?
Hypermethylation of phenol?
Yeah.
I would rather go directly to classical process using Miyamoto and Togni. I'm sorry, the answer is not very sufficient maybe, but the question is quite broad. So, or you can also maybe envision to functionalize your alcohol with a directing group and then to ensure activity that way. It really depends the challenge you want to address and where you want to introduce a CF3 group, I would say.
Okay. Thank you. Moving to the next question. Is the polyfunctionalization done in a single pot with sequential addition, or it is whether it is a single pot reaction or it is sequential addition reaction?
Okay, so it's a one-pot process and it's a sequential sequence. So that means that we first do the methoxylation and we find suitable condition to have only one ortho CH bond, which might be functionalized with this O-methoxy. And since we never observed any difunctionalization ortho prime COMe bond formation, and with this optimized condition, then in the same pot, we just need to add the sodium halide, more PIDA, and then we can undergo the next step using this methoxy as a donating group, and then favoring this para-oxidative functionalization. But there is no treatment, no filtration. I mean, it's really a one-pot process. You just need to run the reaction for 20 minutes or run, depending on the substrate, you need to follow up, and then you just add extra reagent and you get a product.
Okay, thank you. Moving to the final question. Does the newly made electrophilic sulfur reagent show fluorescent properties?
I'm sorry, I might have some issue with my connection, I guess. Could you repeat again?
Does the newly made electrophilic sulfur reagents show any fluorescence properties? Are they fluorescent?
That's a very good point. I mean, we didn't go so far in that direction, but that will be very interesting to look after it. Yes. Thank you. Thank you very much.
Yeah. Thank you. Thank you, Professor Besset, for your responses.